Investigating piecewise explicit formulas. We've learned that sequences are functions whose domain is over the positive integers. This is true for other types of functions, including some piecewise functions. Recall that a piecewise function is a function defined by multiple subsections. A different formula might represent each individual subsection. Given an explicit formula for a piecewise function, write the first n terms of a sequence. Number 1, you're going to identify the formula to which n is equal to 1 applies. Number 2, to find the first term, a subscript 1, we're going to use n is equal to 1 in the appropriate formula. Number 3, identify the formula to which n equals 2 applies. To find the second term, a subscript 2, you're going to use n is equal to 2 in the appropriate formula. And then you're going to continue in the same manner until you have identified all n terms. So for example number 3, writing the terms of a sequence defined by a piecewise explicit formula. We're going to write the first 6 terms of the sequence. So a subscript n has 2 formulas. The first formula is n squared. N squared if n is not divisible by 3. The other formula is n divided by 3 if n is divisible by 3. So we're going to find the first 6 terms of the sequence. So we're going to substitute n is equal to 1 all the way to 6 into the appropriate formula. Again, we're going to use n squared when n is not a multiple of 3, and use n divided by 3 when n is a multiple of 3. So let's take a look at 1. Okay, 1 is not a multiple of 3. And so since 1 is not a multiple of 3, then we're going to use n squared. So the first term is we're going to let 1 equal n. So 1 squared gives us 1. Next, we're going to look at number 2. And 2 is not a multiple of 3. So again, we're going to use n squared. So the second term, a subscript 2, is going to equal n squared. We're going to substitute 2 to be n, and 2 squared gives us 4. Next, we can see that 3 is a multiple of 3. So we're going to use the formula n over 3. So a subscript 3 is going to equal n divided by 3, and that's 3 divided by 3, which is equal to 1. Going back to now 4, 4 is not divisible or a multiple of 3. So we're going to use n squared. So the fourth term makes n equal to 4, and 4 squared is going to give us 16. 5, the next number, is not a multiple of 3. And so therefore, we're going to use the formula n squared. So the fifth term is going to be n squared, which is 5 squared, which gives us 25. The last number that we're using for the sixth term, 6 is a multiple of 3. So we're going to use n divided by 3. So a subscript 6, which is the sixth term, is n divided by 3, and 6 divided by 3 gives us 2. And so therefore, the first 6 terms are the following: 1, 4, 1, 16, 25, and 2. Now every third point on the graph shown in figure 4 stands out from the 2 nearby points. This occurs because the sequence is defined by a piecewise function. So the first ordered pair was 1 and then 1, and there's our ordered pair 1, 1. The second ordered pair was 2, 4, so there's 2, 4. And then the third ordered pair was 3, 1, and there we have 3, 1. And then 4, 16 was the next ordered pair. 5, 25 was the next ordered pair. And then 6, 2 was the last ordered pair.